So you are learning how to deal with those, and you're feeling your way through life. So it's interesting to interact with young people and to see some of those things that you're dealing with and grappling with as we go through life. Now, some of the times it does us good to just, instead of looking at the minute details of life, just step back and take a look at the big picture. Sometimes we miss the forest for all the trees. We're looking at all the individual trees and we miss the grand scheme of things. And that is something that the Lord does for us at times when we happen to step outside at night and we happen to be looking up instead of looking down at our glowing screens, and we just see a vast expanse of the universe silently pinwheeling overhead. And maybe at those times is when we stop and consider for just a few seconds, which is a long time in this day and age, and we look at what's out there. And you know, when you look up in the universe and you see those stars so far away, they look like they're so far out that they completely destroy our depth perception, leaving us feeling like we have no idea how far they are out there. And we feel like we're lost in the middle of nowhere, yet surrounded by everything at once. And it's at that time that God can come in and speak to us as He shows us the big picture. And as we stop and consider our tiny place in this enormous universe, and it kind of puts me back in my place when I give a little time for that, and I recognize that the universe actually doesn't revolve around me and all of my concerns in life, but yet there is so much out there that God has made and that He has going on, and I'm just a small part of it. And even though I'm so small in it, God loves and cares for me. So God has a message for us coming from the heavens, and He's preaching this message to us through the stars and through the heavens. This is a secondary or even elementary message that He has for us. It's not a primary message. It's not necessarily the most important message like the Word of God here and the Spirit of God speaking to us, but we have a message in Psalm 19:1 where it says, "The heavens declare the glory of God." So they have a specific message where they are explicitly declaring the glory of God for a very real purpose, and that's to show God's glory to us and to speak about Him. There's one verse that I'd like to start off with here this evening, and I often like to do this on a weekend like this, is to share Psalm 89, verse 5, where it says, "And the heavens shall praise thy wonders, O Lord, thy faithfulness also in the congregation of the saints." It sounds almost like a prophecy for us this evening here. We have a congregation of the saints here, and we're preparing for God to speak to us through the heavens that He's made. So the heavens shall praise thy wonders here this evening in the congregation of the saints. We have a great creation to consider and an even greater God to learn to know. So as we go through this evening, we just want to take a look at kind of what's out there and how far it is from us so that we can get a little better understanding of maybe some of the facets of our Creator that stretch our minds, our comprehension, our understanding almost to the breaking point. And then we can maybe get a little different view of our Creator, maybe not necessarily one that's more complete. It's not that we're lacking anything if we don't understand how the heavens are, but we definitely can, as we look into God and the things He's made, then we can definitely learn and find things that are a blessing for us. In fact, when the Lord saw that there was a man that He loved and it was righteous, and he was so righteous that He even talked to his arch enemy about him, saying, "Did you notice my servant Job? When he was sick and when he was in trouble, the Lord came down when he was at his low point, and He gave him a creation presentation. He asked him over 50 questions of things that pertain to the things that He created, and He revealed lots of things to Job in order to encourage him and lift him up. And so He can do the same for us this evening. As we go through this evening, if you keep your eye on the lower right corner of the screen, you may see an R logo. That means real, stands for real. When you see that, you know you're looking at real pictures. But this picture that you see here is actually a composite, so that's the reason for the little word next to the R. It's a composite of about 6 different images put together into one. So if you would look into a specific region of space, you wouldn't see this compilation of objects as you see it on the screen. But I took some Hubble Space Telescope images and I put them together into one image, just so you can see some of the variety of the objects that are out there in the universe around us. And we have things like Saturn here, and over here we have Neptune. This is part of the Omega Nebula, part of the Carina Nebula, part of the Orion Nebula here, and the Omega Centauri star cluster. So lots of different types of things that we can see and enjoy. Next, we will take a look at the structure of the universe and see how it's all put together, starting with the Earth here. This is the most familiar part of the universe because it's where we are, where we live. And we are basically locked here, gravitationally locked to the Earth. But there's a lot going on around us, and we can look outside of the Earth here with a naked eye and see the other things in the solar system around us. So the next view here is showing how the Earth is a small part of our solar system, third planet out from the sun. This cube should be about 20 to 30 times bigger to include all of the outer planets as well, but I'm limited for space here. So this is also, in this cube is where a lot of the asteroids are. A lot of comets pass through this area. So comets, asteroids, planets, those are all in this part of the universe. But if we extend out much further, we come to an overview of the Milky Way galaxy. Most stars that we see are actually arranged in groups like this called galaxies, and this is the Milky Way galaxy. It's called our home galaxy. Then galaxies are grouped into clusters, like you see here. There's about 30 members in our local cluster. That's the name of the cluster that we're in. And then these clusters are actually grouped into clusters of clusters that are called superclusters, and you see an illustration of that right here. We are within what's called a Virgo supercluster, and then there are other superclusters of clusters of galaxies all across the universe, all around us. Now, if we step back and take a look at all these clusters of clusters, these superclusters, we don't know exactly what it looks like because we can't step outside of the universe and look in, but when we look from inside out through it, we can see that there is another structure that we're only seeing a part of, since we can't see all the way to the end of the universe. Every time we build a bigger telescope, we see even farther. So we don't know what the grand scheme of things look like, but we know that from here, it looks something like this. So there's a filamentary web of strings and voids of superclusters of galaxies. And telescopes, the new telescopes that are being built now, like the James Webb telescope, are so powerful that they actually have to look at a different wavelength of light to see, in essence, beyond the horizon. So they're looking so far out across the universe that they can't even see anymore with visible light, since stars that are out there are moving with the expansion of the universe away from us to where their light is shifted into the invisible part of the spectrum, and we have to tune our telescopes to look at that invisible light in order to even be able to see them. So it's a tremendous distance that we're looking out there. There's an incomprehensible size in the universe, but the one who created these things is far more incomprehensible in his nature. But he reveals to us everything that we need to know about him. So let's take a look at how big these objects are. Isaiah 40 verse 26 says, "Lift up your eyes on high." This is a command. And then it says, "And behold, not just those things that you're seeing, but the one who hath created these things." And it goes on to say, "That bringeth out their hosts by number. He calleth them all by names by the greatness of his might." So when we look up and we behold these things, we see twinkling stars. And if you look close, you can see these stars are kind of twinkling. They're moving around up there on the screen. And this is these are actual pictures of stars in slow motion. So they've been slowed down 10x. And if we zoom in on one of them, you can see what's going on in a 10x slow motion video here. You can see how the star is being fragmented, is jumping around, and this is the actual twinkling action of a star. So stars are so far away that even though they're so large, They appear to be a point source of light here on the Earth. So as this point source of light is shining through the atmosphere, heat waves rising and the jet stream above and other disturbances cause this ray of light to be shifted back and forth and partially extinguished, and it makes a star look like it's twinkling. So the farther the star is down toward the horizon, the more it seems to twinkle. The stars straight overhead don't twinkle as much because they're not shining through as much of this thin blanket of air that surrounds the Earth. So they look so tiny. They look like flickering candles that could be snuffed out with a blast of wind, but that belies their true nature, one of being thermonuclear furnaces that are continuously detonating in the sky, just like a giant, super powerful hydrogen bomb times actually billions, to be precise. And we may look at that later on. So what we have here now is we'll just step away from the stars and go back to the smaller things like planets. We have the Earth here on the left side, and it's right here. Let's see, can you see that? I think we can see it. And then we have Venus. Over here is Pluto, dwarf planet, Mercury, and here's Mars. These are what we call the terrestrial planets and dwarf planet. These are ones that have solid surfaces. The other planets that are much bigger than the ones that we just looked at, which are circled now in the bottom right corner, these other ones that have been added are called gas giants or ice giants. This one here is Neptune, this one is Uranus, this one is Saturn, and here is Jupiter. So Jupiter is much bigger than any of these other planets. Saturn is close to it, but Jupiter is big enough that we could fill it with 1,000 planet Earths. You've probably heard that when you were in school, and maybe even since then. So it's much bigger than the Earth. It's a fascinating planet. But if we take Jupiter and the other planets and make them smaller and compare them with the sun, we can see how the sun is much bigger than even Jupiter. It's big enough that you could fill the sun with 1,000 planet Earths before you fill the volume of the sun. That's, of course, if you take out all the empty space and make Jupiter malleable and you fill it up with Jupiters. And then here we have the Earth that's just a speck. You could fill the sun with about 1 million planet Earths. Now, the sun is what's called a main sequence star. So if it's in the main sequence, it's kind of like an average in some way, average star in some ways, but it is more massive than most. And there are other stars that are even much more massive than the sun. We've added a few of them here, Sirius, which is the brightest star from our perspective here in the night sky. And then there's Pollux, and there's Arcturus. Arcturus is a giant star. It's out of the main sequence. It's not in that same category as the sun, but it's a giant star, and it's named that for good reason. It's enormously large, but it's small compared to Rigel, Aldebaran, Antares, and Betelgeuse. These stars are called supergiants, so they're much bigger, and it's hard to comprehend how big Betelgeuse is, but what we can do is bring it into our solar system to an area close to us, and we can see how big it would be if we would place it right where the sun is now. In that case, we'd bring it in to our solar system, and it would be big enough that it would swallow the entire inner solar system, swallow the Earth here, about 93 million miles away from the sun, extend beyond the orbit of Mars, and even likely swallow up the orbit of Jupiter way out here. So if you can kind of imagine looking up at night and there's Jupiter above us, we can see Jupiter in the evening right now. Jupiter is above us 5 astronomical units away, close to 500 million miles above us, and the sun is way down below us. If the sun were to start growing to the size of Betelgeuse, it would come up until it would swallow the Earth and move millions of miles beyond us and even go out into space beyond us and swallow up Jupiter as well. So Betelgeuse is a star that's big enough that if we were to try to fly the distance from the edge of it into the center of it, just halfway across, just the radius of this star, it would take us anywhere from 50 to 80 years flying at about 600 miles per hour on a Delta jet, for example. And the reason it would take a range of time like that from 50 to 80 years is because it would just depend on when we get started. This star is so big, massive, and unstable that it actually oscillates in size. There are enormous eruptions of energy and even matter coming off the star, so huge billowing plumes come off the surface, and it grows and collapses in size. It's going back and forth almost like a hyperventilating pufferfish as it gives off all of this tremendous energy. So one of the things we can be thankful for is that God gave us a very stable star, one that can be under control here, giving us a regular output of energy. So moving on here, back to Betelgeuse, and there's one other star that I'd like to show you coming up in the background here. It's called VY Canis Majoris, and it's about twice the diameter of Betelgeuse. These stars in this category are called hypergiants. So it's almost like the Lord just wanted to give us one final dose of His greatness and what He can do. So God has created these stars. They're so far beyond our comprehension, and we wonder, how did He do it? How did He make just one of them? The Bible tells us exactly how He did it. By the word of the Lord were the heavens made, and all the host of them by the breath of His mouth. So it's telling us that God just breathed the stars into existence. And all these stars look like they could just be a vapor cloud from the mouth of God. Like you see on the picture here, it's kind of like an illustration for this scripture that we just read. But how much does that help us when we know that the Lord just spoke the stars into existence? It doesn't really do a whole lot for me, except that there is a realization that we have that matter is just simply encapsulated energy. So it's energy put together into a solid state, basically. Einstein told us that there's an equation called E equals mc squared. And one of the outworkings of that is that we can find that we can take matter and convert it into energy, or we can take energy and convert it into matter. So there's a back and forth relationship. It's kind of like two manifestations of one thing. And when we see how that God just released His creation, His energy at creation, and encapsulated into all these stars and things, then it helps us to understand how that the power of God was able to just create these things out of pure energy. Einstein noticed that all matter that we have around us is just pure pulsating energy that's locked up in a state of matter, in a solid state. So it is the power of God that's been encapsulated all around us. Now, what's amazing is how much energy there is in matter. There's one thing that helps us understand the tremendous amount of energy that's in matter, and that is the amount of energy that it takes to create a nuclear explosion. Back in 1945, there was a bomb that was dropped on Japan, and it was a terrible event. There were tens of thousands of lives that were lost from that single explosion, and basically the entire city was flattened because of one atomic bomb. And nuclear physicists tell us that there was some matter that was completely annihilated at the atomic level. It ceased to exist as solid matter and was converted to pure energy. And that release was so violent that it destroyed the city. And what's astounding is the amount of matter that had to be destroyed in order to get that level of destruction. And we were told that it was only 0.9 grams or 1/30th of an ounce. That's about the weight of a paperclip and about a fingertip-sized pile of dust. So if there's that much energy that God encapsulated into that much matter in the beginning, how much energy is encapsulated in your body or in this building or this planet? Then think of all those stars all across the universe, and it's astounding how much energy God put in the universe in the beginning, and it makes us think it's no wonder that there's actually lightning coming from the throne of God as we read in the Bible. So God is a God of great power. To whom then will you liken God, or what likeness will you compare unto Him? And this is a star. It's the closest one to us. It's the sun. And if these are the biggest natural, most powerful natural things that we know of, then it is what we would use to try to compare God to as an analogy, but they fall short because they are just compared to the breath of God. And in that case, we have nothing left to truly compare God to in all of creation. There are so many of these stars all around us. These pictures that are coming from the universe astound us with the sheer number of stars. The pictures that I'm showing you this evening. If there are no credits on the pictures, they're normally taken either by a telescope we have at home or by NASA, which is, those photos are in the public domain. So this picture here came from a telescope at home. Two clusters, one blue and one yellow, right next to each other, just kind of illustrating the tremendous number of stars all around us. And when we look up through those stars, we see things like this, the Andromeda Galaxy, up in the upper center of this image. If you use the constellation Cassiopeia, which is like a smashed W or M, you can use the side of it that's not quite as smashed as an arrow that points roughly toward the Andromeda Galaxy. And the Andromeda Galaxy is just a little over one Cassiopeia length away from the end of the arrow. So that's a good way to find it. At this time of the year, it's almost directly overhead. It is, if you look almost straight up, you will see the Andromeda Galaxy up there. And it's just a faint smudge of light. You need to look for it on a night when there's no moon, when there's no city lights close by, because it's a little hard to see. But in that smudge of light that's small enough that you could blot it out with one thumb held at arm's length is a collection of stars that you see in a close-up image here, that was taken with the 10-inch telescope at home. And in this collection of stars, there's estimated to be 1 trillion stars. And if we were to count these stars at 1 per second, it would take about 30,000 years to count all these stars. And they're hidden behind one thumb. I don't know if that's supposed to make us feel big or small, but whatever the case, it does show us God's greatness and his power. And when we look at this galaxy, we're looking about 2.4 million light years across space, and it's about the farthest that you'll ever see without a telescope. So it's interesting how that when we're here on the earth, God has just made the earth in such a way that we have a limited vision. And we can only see a few miles off in the distance. If you go out west, on the Great Plains or something, you might be able to see 30, 40 miles or even more in some cases. But when the sun goes down and the glare of light across the sky dissipates, our vision is suddenly liberated to look vast distances across the universe. And for some reason, God decreed that it should be this way, and he speaks to us through these things that he has made. So this is one of the many galaxies that are out there, but there are so many more. This area of the sky, if we look at it, we can see an area right here inside this triangle of stars that looks like a nondescript empty area. Astronomers noticed that when they were trying out their new Hubble Space Telescope, and they wanted to find a place to look, not for what was there, but for what was not there. What they wanted to do was use this telescope to not look at things close by, but look far off into the universe. So they wanted to find an empty hole in our galaxy to look out through and see what was there, if anything, way out there beyond us. So they took the Hubble Space Telescope, they trained it on the central part of this image, and they got an exposure that was a total of 11.3 days in length, allowing light from these distant galaxies to trickle in on the sensors. And this is the image that came back, the Hubble Ultra Deep Field photograph. And there's just lots of points and smudges of light on this picture. So it's hard to appreciate it, but it's one of my favorite images in all of astronomy, not because of its beauty or its aesthetics, but just because of what it shows us and what it tells us about the nature of God. Now, we can't see everything here because of the ambient light and the limitations of the equipment, but there are actually 10,000 points of light and smudges of light on this photograph. Astronomers have basically dissected it and found that. The amazing thing about it is it covers an area of sky so small that if we were to go outside at night, reach down and pick up a coarse grain of sand and hold it at arm's length in front of this area of the sky, we would lose the entire view of what we see here because of it being so great, so large. 10,000 galaxies hidden behind one grain of sand. Now, can you just imagine what all is out there if we could place that grain of sand in other places and work all the way around us in every direction? there would be much more than 10,000 galaxies to look at. So the astronomers that took this image tell us that it would be impossible to see the universe at this level of granularity or resolution in our lifetimes, because in order for them to take a picture of the entire universe at this resolution, it would take about 1 million years with the Hubble Space Telescope, with the way they took this picture. So there's no physically possible way that we can actually explore God's creation just by taking pictures of it from our vantage point here and see everything that's to be seen. So we will continue to learn more about our infinite creator for all of our lives, regardless of how much science advances. And then when we get to the other side, we'll continue to learn to know more about our great and mighty God. Next, we'll take a look at the size of the universe and see how far these objects are from us. Is not God in the height of heaven? And behold, the height of the stars, how high they are. Job 22:12 tells us. So starting off here with the distance from the earth to the moon, it's about 238,000 miles away from us. Relatively close. It would take about 20 days to fly there on a jet, moving at about 600 miles per hour. So we'll use this as a reference point. We'll compare travel time to help us understand how far these objects are from us. The next step is the sun. It's about 400 times farther away from us than the moon is, and it's about 92,960,000 miles on average away from the earth. It would take 17 years to fly there. And the next step is going all the way out to Pluto, which is out close to the edge of our solar system. It's about 3.7 billion miles away from us, or 700 years flying on a jet. If we were to travel at 65 miles per hour, it would take about 6,500 years to reach Pluto, which is about 40 times farther from the sun than what the Earth is. So we keep taking bigger leaps all the time, and we still have a ways to go. We are not take us there to Proxima Centauri, the nearest star in the night sky, and 4.2 light years away is where it sits. 24,689,719,000,000 miles approximately. It's about 6,800 times farther than Pluto that we just looked at, and about a 4.7 million year flight. So it would be extremely difficult to reach the nearest star in our lifetime if we would try to go there. And it's not possible with the current technology and means that we have right now, but of course there's lots of ideas on how to get there. So we've switched to light years here. And I don't want to leave anyone behind, so what we'll do is we'll explain light years before we go further. And a light year is the distance that light travels in 1 year. It's about 186,000 miles per second in its speed that it goes. So that's fast enough to go around the earth about 7 times in 1 second. And that's faster than you can get to church on Sunday morning when you're running late. It is much faster than anything that we can comprehend and imagine. Yet, even light seems to slow to a crawl when we're looking at these enormous distances across space. If you let this light go for 1 year, it gets up to nearly 6 trillion miles in distance away from us after traveling for 1 year. 6 trillion doesn't seem like that much of a big, like very big of a number. In fact, if we look at these two figures, even though they're describing the same speed, this actually sounds faster than this 6 trillion at the bottom, because this 186,000 miles per second is a bite-sized chunk that we can process a little better than this big number. So this tells us that we're not fully comprehending these numbers, so we can't expect to comprehend the distance across the universe either. So first we'll have to get a hold of these numbers, so we'll quick do that before we go on further. And here is a scale from 1 to 1 billion. And as we leave 1, we have to go through the tens and then the thousands, then the hundreds, tens, hundreds, thousands, millions, before we get to the 1 billion here. Where do you think that 1 million should appear? A lot of times we kind of have this idea that it's close to the center, even though we know it's closer to 1. But the actual proper location, since I have 100 dots here on this scale, is 1/10 of the way to the first dot. Then we have all the distance left to cover before we get to 1 billion. And it's the same way on a scale from 1 to 1 trillion. We have to squeeze in the tens, the hundreds, the thousands, the millions, and the billions before we get to 1 trillion. Where should 1 billion appear, this number? It's actually 1/10 of the way till we get to the next, before 1/10 of the way to the next dot. And there we have 1 billion. That means the entire top scale is squeezed into the tiny space between. 1 in a billion, and we have all the distance left to cover before we get to 1 trillion. Now, moving outside of our local neighborhood of stars, we can step out and look at the Milky Way, an overview of it, and there's the sun about 2/3 of the way out from the center of the galaxy, and there are stars that are close to us, and we can see them without a telescope. Most all of them are contained within this little yellow circle, so we're not seeing much of what God has created even in our own galaxy. We can see the background glow of these stars out here. We call it the Milky Way glow. And if we were to take the sun and the solar system, right where I'm pointing out right now, and all the planets around it, take the entire realm of the solar system where the planets are, and if we were to expand it to where we can actually see it here on the screen and we can get an impression of how big it is compared to the entire thing, if we were to make it about the size of a quarter, which is about the size of the main part of my pointer there, maybe just a little bigger, then we would have to make the Milky Way galaxy correspondingly larger. And in that case, it would have to be 2,000 miles from one end to the other in order to be at the right scale with the quarter-sized solar system, which is the region of the sun and the planets. So we've taken an enormous step here going out to the Milky Way. It's estimated to be about 100,000 light years across, contains over 100 billion stars, and is just one of many. The nearest major galaxy to us that we looked at earlier is 2.4 million light years away, at least. Some feel it's even farther. This is a tremendous distance. It's in light years. We can't understand that very good. It's a confusing unit of measurement, and astronomers do this. They use units like light years and parsecs and megaparsecs and astronomical units. They use it for a good reason because miles just aren't sufficient. We get into these enormous numbers like this one here, which is in the 14 quintillions, to try to describe the distance to our next door neighbor, which of course it's obvious that we need some other unit of measurement like light years. And then there's other galaxies that astronomers have found 5,000 times farther away and more as bigger telescopes are being built. Isaiah 40 verse 12 says, "Who hath meted out heaven with the span." So all of this is picturesquely described in this analogy form of God sitting on his throne and just measuring out the universe with a handbreadth. Now, this is not saying that God has a physical size that's much greater than the universe, because God is a spiritual being. He's also omnipresent, but it is telling us that God is much greater than anything he's created. O Lord, our Lord, how excellent is thy name in all the earth, who has set thy glory above the heavens. So God's glory is much greater than anything that we've seen. Now, here, right at the end, I'd like to just quickly go through a few things to help us see the creativity of the Creator. And we'll do this by looking at things he's made around here in the solar system. So what is astounding is the fact that even though there are so many stars out there that we just absolutely can't count them, there are also lots and lots of planets, other worlds out there that God has created and fashioned. And a lot of these have solid surfaces, areas that could be explored, places that could be walked on. We can see lots of geological features and tectonic activity and things like that on these places. So let's take a look at some of these. We'll start off with the sun here in the center of our solar system. And we can see some parallels and lessons from the solar system. We're running out of time, so we'll just skip over some of this and look at how the sun is much bigger than the Earth. It has a surface temperature of 10,000 degrees Fahrenheit, burns 600 million tons of hydrogen per second in the core. And as that happens, the sun actually loses mass in this matter to energy conversion. A fingertip-sized pile of mass releases enough energy to level a city, but the sun, astrophysicists have done the calculations, and they've discovered that it loses 4 million tons every second just to maintain its prodigious energy output. So it's getting lighter all the time, but it's no cause for worry because it's so tremendously large it won't run out of fuel anytime soon. According to the calculations, it would take about 5 billion years before it would start to run low in fuel. This is a close-up view of the sun, and when there's more activity on the sun, we see more prominences like you see here, and sometimes These erupt into what's called a coronal mass ejection, or a CME. And I'll actually put this into motion, and you'll be able to see it here just shortly. And start it. This is time-lapse photography, so it's like in fast forward. And the Earth now is at the scale of being about the size of my cursor on the screen, if you can see it there. No, it disappeared. So it just shows us some of the intense energy output of the sun. This is caused by a coronal mass ejection or other solar wind coming toward us and lighting up the night sky. These are called aurora borealis, or the northern lights. There was one year we were in Alaska, and it was just kind of an ordinary night for northern lights, but for me it was extraordinary as a boy from the South who hardly ever sees things like this. So I set my camera on the ground, got a few 6-second exposures, and it was amazing to see the display in the night sky there. And then just recently, this past year, or the year before, we had an amazing display of northern lights all the way down in South Georgia. We could see them to the north and even turn around and see them to the south of us, about 40 degrees above the horizon. So it was fascinating to see these lights, curtains of light across the sky. So what's happening here is parts of the sun, particles from the sun, are raining into the atmosphere, and they interact with the gases in the atmosphere as they follow the magnetic field lines into the Earth, and they ionize the gases, causing them to glow, and it leaves these glowing. So the sun can wirelessly generate light in our atmosphere. It's extremely powerful. It has 3.8 times 10 to the 26th watts of power, 380 septillion watts, which is hard for us to comprehend and understand. So basically useless. But what we can do is compare it to man's greatest accomplishments. So we could have a thought experiment. How do we compare to God? Of course, we know we fall far, far short, but just this one little star next to us here, how does it compare to our greatest accomplishments, like a atomic bomb or a nuclear bomb? There was a nuclear weapons test that was done here in the ocean, and we'll just start this, and I want you to watch as it goes. And it could be that it won't work with our setup here this evening. And let's try one more thing, see if we can get it to work. Apparently not, so that's okay. The sun gives off as much energy as 20 billion of these typical hydrogen bombs detonating at once. So it completely dwarfs the energy of anything that mankind has assembled. And then there's other stars like the Pistol Star that completely dwarf the sun. It is one of the most powerful stars that have been found. It is 10 million times more powerful than the sun and releases as much energy in 6 seconds as the sun does in an entire year. I don't know if this is accurate or not, but one thing that we do know is that the sun is giving off, or this star is giving off so much energy that it's casting its outer layers into space. And as you see here, the star is basically disgorging itself as the outer layers of it are being caught up in this energy outflow. So the Lord saves. Praise ye him, sun and moon. Praise him, all ye stars of light. Let them praise the name of the Lord, for he commanded, and they were created. Next, we'll take a look at the planets moving out from the sun. Mercury is traveling at 30 miles per second. It's 800 degrees in the daytime, 280 degrees below at night. Mercury is one of the least seen objects close to us. And it's not because it's too far away, it's because it's too close to the sun. Most of the time it's lost in the sun's glare, but if you know just when to look, you can see Mercury just far enough away from the sun to be visible. And that's a lesson for us. We should be like Mercury. We stay so close to the sun that people don't see us and our own fleshly desires and goals put out front, but yet they just see the glory of God surrounding our lives and the things that we do. Venus is the next planet that we come to as we leave, go further out in the solar system. It's the brightest point of light in the night sky. It has clouds that are made of sulfuric acid, which is the same type of acid we have in our vehicle batteries. It has an atmospheric pressure of 1,323 pounds per square inch, crushing down on every half inch of the planet's surface, or excuse me, every square inch of the planet's surface. It has a temperature of 860 degrees Fahrenheit, twice the heat of a conventional oven. So this is an extremely inhospitable place, and it's not a good place for astronauts to go and visit because it is just not at all conducive for life. Any astronauts that would go there would be crushed, cooked, and corroded before they'd even get to the surface. It would be awful. But it could be done maybe if things are done just right and it's kept extremely short. And it would have to be well done, or else the astronauts would be well done when they come back. So the reason I'm bringing this out is because this is a planet that's right next to the Earth's orbit. So if any place should be able to support life in our solar system, this should be one of the candidates, but things have gone awry here. It's because the Lord has not designed this planet to support life. There are so many parameters that need to be set just right for a place to be able to experience life. And if you study the sciences, you will notice that one of the leading frontiers and the greatest questions of science today is, why is it that it appears to be an anthropic principle at play in the universe? Thinking men like Roger Penrose have run some calculations, and they have seen that it is so entirely improbable that, completely discounting the arising of life here, but just the fact that the universe can be suitable for life or comfortable for life to exist, the odds against that are so astronomical that it begs that there is no explanation within this universe. They've actually had to reach beyond the universe to come up with an answer, which we have done as well. We have brought the answer to the Creator God, but they have conjured up countless trillions of other universes to explain our one. It's called the multiverse theory. Maybe a little more on that later on. But God is the one who's created these things, and He receives glory through them all. So we won't stop at the Earth here this evening, but we'll take a look at the moon. And as we brought it up closer, you can see lots of craters, mountain ranges. We can zoom in on this one here, the crater Eratosthenes, the Apennine mountain range on the right side of the moon. We see lots of craters, heavily cratered region. Be sure to take a look at the moon through a telescope if you get the chance. You will see craters like this through any telescope. This is the crater Clavius, a large crater with a semicircle of 5 smaller craters in the crater floor. So we will stop with that. I'd like to summarize with a verse right here from Psalm 33, 8 and 9. God, through His creativity, has made all these things. He's made countless planets all across the universe with lots of things to see and study on these planets. They're declaring His creativity and His glory. God is an interesting God to serve and to follow, and He is a powerful God to serve, who is existing in our lives. Let all the earth fear the Lord. Let all the inhabitants of the world stand in awe of Him. For He spake, and it was done. He commanded, and it stood fast. I have some cards with me here this evening. If you care to, you can feel free to pick up some cards. They're on the back table there, right there at the sound booth. So you're welcome to help yourself. There are astronomical events for this year. Okay, thank you for your attention here. That is all I have for this evening. Is there anything else that should be done? Okay. Blessings to you. Look forward to seeing you later on. Well, I'm sure everyone has a testimony, but probably not going to take